Welcome to 7.RP.2. This is goal number 2, and in this goal you are going to be working on representing proportional relationships in equations, and you are going to be able to identify the unit rate in tables, graphs, equations, diagrams, and verbal descriptions. So to get us started, let's talk about solving proportions. So proportional relationships are equations that state that two rates or ratios are equal. So it's an equation stating that two rates or ratios are equal. So we can say here 4 is to 2, or maybe 4 bags of flour equals $2, and that is the same as saying 8 bags of flour is equal to $4. We know that these are equal. Essentially, our scale factor to get from 4 to 8 is essentially we're multiplying by 2, and we can say that that scale factor holds true for the bottom half as well. So sure, that works for these sort of proportions like this. This is a pretty easy proportion, and we would be able to solve for, if we did not know that 8 was there, we'd be able to solve for 8 pretty quickly. 2 to get to 4, for 2 to get to 4, we have to multiply it by 2, so 4 to get to whatever it needs to be, we'd have to multiply by 2, and we'd get 8. Awesome. We can solve those without having to do anything sort of crazy. Well, every once in a while, you'll end up with some crazy numbers. We know the world does not always work in happy, peachy strawberry fields, and it's not always super easy for us to find proportions that work or that are pretty numbers. So that's why we're getting into decimals and fractions. So this property of proportions essentially helps us deal with those situations where we have products of numbers that are fractions and decimals. So in this case, what we can say is the cross products of a proportion are equal. And essentially what it's saying here is essentially if we have a proportion A over B and we have another proportion that is C over D, if we were to multiply A times D, that should be equal to B times C. So essentially, let's actually try this. So we're essentially creating a big X, a big cross in everything. So let's try a couple of numbers. If we had 4 to 2, take that flour to dollar ratio, and we have the situation 8 to 4, essentially their cross products should be equal. So if I said 4 times 4, we have 4 times 4, that should be equal to 2 times 8. And 4 times 4, this equals 16, and that is equal to 16. So yes, this whole thing checks out. Essentially, we are multiplying 4 times 4, 4 times 4, and then 2 times 8. So we're making a big X out of everything. So let's try this concept with another problem. So our problem is this. We have number 1, B divided by 15 is equal to 66 divided by 90. So if we wanted to, we could totally do this with scale factor, and we could figure out how many times does 15 go into 90, and we'd find out that it's 6 times, and that would be phenomenal. Or, yeah, 6 times, and that would be phenomenal, and we'd multiply the top by 6 and the bottom by 6, or we'd divide by 6, or whatever we needed to do. But let's try to get away from that just briefly and try a new method. So instead of that, we're going to say 6 times 90, or B times 90 is equal to 15 times 66. And then from there, all we're doing is solving for this B. We're just trying to get this B all by itself. So what we're going to do is, let's do a little bit of math here. 15 times 66, we can do that math. It equals 990, and that is equal to 90 times B. And then after that, B is being multiplied by the 90, so we could divide by 90 from both sides. Divide by 90 on both sides, and we will get B is equal to 11. So there is our final answer. B is equal to 11. So essentially, we would then be able to replace this. We could say 11 is to 15 as 66 is to 90, and so we should see the same scale factor. To get from 15 to 90, we have to multiply it by 6. To get 11 to turn into 66, we have to multiply it by 6. So we have the same scale factor here, which is what we want. Let's try another problem. We have 6.8 over t is equal to 34 divided by 50, and so we're going to do the same exact thing, scale factor, or like cross products. We have 6.8 times 50, and that is equal to t times 34. So let's do some of this math. We have 6.8 times 50, and that gets us 340, and that is equal to t times 34. I have t times 34, so we need to divide by 34 to make everything equal. So 340 divided by 34 gets us 10, and that is equal to t. So there's our final answer, and we can actually put that in our original equation. We had 6.8 divided by 10, and that is equal to 34 divided by 50. And so we could actually see, okay, how do I get from 10 to 50? Well, I'd have to multiply by 5. And if I did 6.8 times 5, would I get 34? And I sure do. 6.8 times 5 is equal to 34. So this checks out and is perfect. One last problem, because you're going to have to actually make proportions out of word problems in this chapter. Ms. Drossick paid $30 for 4 students to visit an art museum. Find the cost for 18 students. So in this case, what's super duper helpful is we make sure that we create ratios that are going to make sense. We see one ratio here, $30 for 4 students. So we can write that as saying costs $30 for 4 students. We could develop a unit rate out of that, and we could say $30 divided by 4 students would get us a certain amount of money, and that unit rate can help us a lot. What we can also do is say this is equal to the cost, which we don't know. All right, and that is over 8 students. So we don't know how much 8 costs for, or 18 students, sorry. So we don't know how much that cost is. So we have a cost that we don't know, and I'm actually going to call this cost C. So it's a dollar we don't know, and how much is it going to cost for 18 students to visit said art museum. So at this point in time, we can actually do the cross product property. We have 30 times 18, and that is equal to 4 times C. And so also, I'm going to not move on very quickly, but if we look at this, here's one ratio, the cost for 4 people, and then we have another ratio, cost for 18 people. And what you also should notice right here, if we look horizontally, we have the people, and then if we look horizontally again at the higher rows, we have dollars. So you can see that everything's set up like dollars and people versus specific ratios that go with each other. Everything's lined up properly. I don't have essentially dollars on the bottom down here and people up top, and then people here and then dollars up top. We don't want that to happen, because that actually will end up making more of a mess. So now let's continue on. We have 13 times 18, or 30 times 18, and that's equals to 4 times the cost. So 30 times 18, we need to do that math, and we get 540. And that is equal to 4 times the cost. And so now we're going to divide by 4, because we have a multiplication by 4. Divide by 4. And so we have divide by 4. And so that cost is going to be $135. This is how much it's going to be for 18 people. And actually, let's check this now with our unit rate. If we were taking 30 and dividing it by 40, or $30 divided by 4, we could find the unit rate of $7.50 per person. And that's pretty good. So essentially this $35 should essentially be 18 times that 750. And so if I were to multiply 750 by 18, I get $135. So this checks out. It's all set and ready to go. I hope this helps. Use this concept of cross products to work through the goal number 2 of 7RP2. Thank you so much. Bye.